Let's get started. Thank you, everybody, for joining in into the Enterprise Rack Challenge, hosted and run by Time to Act Group Austria, namely AI Strategy and Research Hub. And in this interesting challenge, we were trying to push a little bit state of the art in building AI agents. So we created this environment that was based on the history of different AI cases, which we've discovered through AI research and for various customer cases at Time to Act Group. And in this challenge, your task was to build an agent that is capable of running as a chatbot in an enterprise company. And the tricky part, the challenging part, is that the agent had to use a lot of different tools to accomplish the tasks. So if we go to the Enterprise Rack Challenge platform. So the challenge was ERC3 Prod, the competition. And it had 103 tasks, which were fairly or not even fairly, they were really complicated. They were more hard and more difficult than what a usual chatbot usually encounters. And your chatbots, they had to use a lot of APIs, pretty much like a normal chatbot deployment in an enterprise. And these APIs, they were more complicated or more unwieldy than a usual API. That was to be expected. And the task sounded like that. So, for example, who is the team lead on E-code compatible primer tier trial, which is actually the name of the project? Or in which project is Miloslavich Igor involved? So like the names were sometimes paraphrased, and they were referring to the internal systems that were simulated by this API. So in that enterprise, they had essentially system for managing employees, and the system for managing employees also included skills and wheels management. And you've learned all that very intimately while developing and debugging agents. It also had its internal knowledge base, which is an essential in any modern enterprise. It had its own CRM system for managing customers and projects, and time logging system. What was new in this challenge is that things were changing. So if we just simply reload this page and reload every time, the tasks are always changing. And the reason for that is that we're running simulation. We're simulating this enterprise company, and behind the scenes, there was actually an entire world. And some parts of that world were fixed, some parts of that world were not fixed, meaning that it was pretty much impossible or really difficult to build an agent that would be trained in advance. So this was a pure testing environment. And your agents were actually doing pretty great job at that. And the tasks were complicated. There were some tasks in different languages. There were a couple of tasks that violated security. There were a couple of tasks that were speaking Chinese, for example. There were tasks that violated security unknowingly. There were tasks that violated security unknowingly, and they were really, really difficult tasks. And unlike the previous challenges, there were no feedback. So basically, if you would go here and if you try to complete the task, the system would not say what was the result because this was a blind testing. Just a second. Let me see as I'm talking if there are any comments. Oh, yeah. So somebody is saying that they're hoping that we'll keep the platform for further tests and developments. Yes. So we're definitely going to keep that platform live and running. We'll figure out how. The only caveat is currently the registrations are paused because they were running on the TimeTact website, and we need to figure out a cleaner way to handle that. So as I'm talking, one thing I'm going to do right now is I'm going to initiate. No, actually, first, let's talk about the outcomes. Let me open the leaderboard. So this leaderboard we're going to publish. And these are the winners. So we had a couple of prize leaderboards. We had the prize leaderboard. We had a couple of focus leaderboards where agents were focusing on speed, locality, accuracy, and budgets. And these leaderboards, they are frozen because these leaderboards, the agents that were running here, they were running without the feedback loop. They didn't have the luxury of actually improving. And this is the hardest possible environment in which the agents will be running. And I'm pretty sure that once the evaluation loop is revealed to you, like it was done in RC free dev and RC free test, community will push the state of the art further. So we'll hear scores that are higher than 72% and maybe even 100. But they will be like pushing based on the work that has been done by the teams that competed right now. And because of that, like these numbers that were completed in the first 3 hours, which was the prize leaderboard, and in the first week without the feedback, they'll be frozen forever. So, speaking of the winners, so the best results, and actually by a large margin, was done by A. Ostrikov, and he was using Claude sequential evolution. And also huge feedback for the teams that provided architectural descriptions for their systems. Because, and actually all the top teams provided gladly their descriptions, which is amazing. And actually some of them might even later provide the source code. And this is amazing because it will help us to push state of the art, because we'll be able to learn and improve. And actually, speaking of learning and improving, later I'll show you an interesting screenshot. So the top place, the first place goes to A. Ostrikov, and he built a platform that actually costs quite a bit for a run. And these are our estimations based on the telemetry that you have been sending. And he's getting 71% accuracy. And the description is basically it's Anthropic Python SDK with a native tool use. And actually, it's an interesting thing is that most of the platforms, most of the agents that were winning, they're winning by carefully tuning prompts, designing additional initial prompts, and then basically carefully designing tools. And even though, like when we were providing the benchmarks, and we provided like each benchmark comes with its own sample agent, and this is was the basic sample agent that was based on schema guided reasoning. The approach that we've distilled thanks to the work with you in the community. And actually, there wasn't too much of SGR in the top leaderboards, which is actually is a good thing because better solutions, they're doing something else. Now we just need to find a way to incorporate that into a coherent, consistent architecture that can work a lot. So the top place goes to Ostrikov. That's the third place. He scored 71% accuracy, and it will be very interesting to see how this agent further evolves once we share the evaluation of the backlog. Now, the second place goes to I don't remember the name. We'll actually need to include that. So the second place goes to the account MMZXEM, which is the last, like the account name is the last 6 letters of the public key of the account. And actually, the second place goes to multiple people. That is quite amazing because you see, like we don't have that many repetitions of the same score among the teams, but there were actually 3 teams, 3 participants that scored the second place, 60% accuracy. So we're not going to have like first place, second place, and third place. So we're going to have one first place and which gets a 500 euro certificate and three third places, all of which have submitted their solutions within the first 3 hours of the prize leaderboard. And this is Simple Agent and DeepSeek Reasoner, which is actually quite cost effective. And there is also another cost-effective solution by Ilya Riz, whom you might remember, because he was the winner of the previous Enterprise Rack Challenge. And Simple Agent and DeepSeek Reasoner was using DeepSeek Reasoner model. The prices are actually estimated based on your telemetry. Sometimes they might be off. but like that's how OpenRouter estimated them. And for example, here we are not estimating the fact that some of the participants were using faster LLM providers like Cerebras or Grok to achieve faster throughput for the local models, and they might cost a little higher. We're providing an average cost based on the current market prices, which are Open Router and which are pretty comparable to what you would get if you were trying to host efficiently these systems on your machines. So we have a function called agent. It uses OpenAI agent runtime and SGR. And as I recall, it was quite tricky to provide telemetry using OpenAI agents. You had to use hooks. So thanks a lot for setting this up. And for each architecture, we provide a couple of additional information points. So, like which models were being used, how many large language model calls were there, how many prompt tokens were, how many completion tokens were there. And also, we're computing on average how much time did the agent spend per task. So I know that some teams were running tasks sequentially. Some teams were leveraging parallelization. So in that case, like it doesn't really matter because we're computing individual task durations individually, and then, for example, we average them. So this is the function calling agent that was using SGR, and here's actually a recurring pattern. A significant part of the work was focused on designing convenient and reliable agent talks tools. Actually, by talking to the teams that were participating, by seeing how community worked, these were two recurring patterns among the winning teams. First of all, they didn't trust the tools that they were given. Which is actually a good thing because, for example, if you're deploying an agent for the enterprise, the tools, the APIs that you will get, they were not designed for the agents. They might be inconvenient, they might be clunky, they might pollute context. And in our enterprise rack challenge, we specifically tried to provide the APIs that emphasize that. They're small, they're chatty, they're inconvenient. And some of the winning teams they were focusing on designing tools that are actually designed for the agents, so that they get results, that they aligned with how LLMs think, and that do not pollute the context. And basically, the other thing, it's which is also a recurring pattern. The teams were trying to work hard to minimize the context. Because agents, like these agents, they are not one-shot LLMs. These agents, they run for a long time. As you can see, like here, an agent can be running for 7 minutes, for 2 minutes, for 39 minutes. And actually, if you look at the recent research, for example, by Anthropic and OpenAI, they show that longer the agent runs, higher is the chance that it will start hallucinating because it accumulates context, it builds up its own tiny echo chamber, and it amplifies mistakes. And mistakes that large language models make without human supervision, they're not logical, they're inhumane, they're stupid. But that's just the amplification effect. And the fact that we have top teams that got high scores on a fairly complicated benchmark, really complicated benchmark. It's more complicated than the real world enterprise deployments. And that these agents were running for, like, for example, 2 minutes, 7 minutes, 6 minutes without human supervision. It actually tells a lot about careful thought that the teams behind them, that their authors put into designing these agents, that they're capable of stabilizing, that they're capable of taking care of the context, of pruning the context. And a lot of architectures that we are seeing here, they are not even sequential architectures. They, for example, take extra care in trying to compact the context. Because we know that there are three hallucination triggers that make large language models hallucinate, and one of them, there is too much junk on the input. So teams were specifically investing time and effort in keeping the context compact and clean. Okay, so we have one first place and 3 second places. And this is the prize leaderboard. These are the teams that have submitted their results within the first 3 hours after the benchmark was created, or sorry, published. And this is the hardest, the most brutal implementation ever. Now, before we move forward, let's see if there are any comments. Judging by the time the first one of the two launches was counted, not the last one. Actually, it could be. I'll need to double check. But let's say we'll freeze the scores at this point. Because I've been double checking, and there were a lot of scores getting closer to the last time. But let me, because I'm actually live streaming, and it's always a good idea to try to change something in the real time. Let me look in the code and see if I messed up the processing. Because what could go wrong? Okay, looking at the code, looking at the leaderboards. And we're picking tail, submitted at. So I'm sorting here all submissions by submitted at descending, which means that, yeah, okay. So that's for the first time, but I'm good. Thanks for the feedback. Let me try to recompute, and we might get different answers right away. So it looks like I messed up. Going to the pipeline, activating, running the leaderboard computation. And also, while I'm running leaderboard computation, let me run the deployment. Okay, back to our. Let's see, did something change? Okay, so actually, there was a change. Let's see how this changes. So Ostrikov is still in the first place. And yep. Okay. Let's see. Function colon. Yeah. So let's say, because that was my fault and my mess up, we'll still have three second places. But like this will be the final leaderboard. Sorry for making this things. So Ilya actually is at the second place. Function calling agent is at second place, and simple agent is at second place. Thank you, Kresnikov, for highlighting that. So basically, to explain what was the mistake is that when we were announcing the prize leader competition, we were saying that uh, teams will be able to have any number of submissions within the prize time frame, but only the last one would be counted. What that was done within the 3 hour period. This was done because like 3 hour is a very short, brutal deployment, and some of the agents might hit an error or exception when computing, but they might still submit the bad solution. And we didn't want to lock the teams into the bad solution. We wanted to give them an opportunity to submit a better solution. That's why we created this mechanic, and it kind of did bite me in the hind here. But long story short, we have this done. And actually, while I'll be talking, the deployment should be finished, and the leaderboard should be. Did it finish deploying? Let me view details. Okay, no, it is not deployed yet. Let me check the source code. And let me make the benchmark public. And let me deploy again. Because what can be wrong with deploying systems during the live stream? Actually, in fact, chances that something will go wrong are too small because I've been deploying in a lot of many times during the competition. Okay, and the deployment is happening when the system is uploading like changed sources, compiling, and showing things steps. Okay, so as of now, the Enterprise Pro Challenge is now public. There are 0 complete sessions, but I'll fix that metric because it's actually probably going through and re-ranking all these systems, all the answers on the server right now. But what that means? It means that right now, if there are gotchas, they will be shown. And actually, if you try to execute any of the requests and you try to complete the tasks, the system will start providing you the reasoning for the scoring. So here, for example, it says, hey, agent should provide one response and found 0, and there were no inference statistics, so we're getting a penalty of 0.1. And it means that probably within 30, 60 seconds, or like a couple of minutes, all of the systems, all of the solutions that were deployed, they'll get the ranking that matches to the ranking on the leaderboard. So you would be able to look back at your existing solution and see the scores and the distribution of things. And you'll be able also to start developing agents and seeing how well or how bad they're scoring. So it will be possible to push state of the art. And actually, it will be very interesting to see like what will be the new state of the art. And speaking of the state of the art, let me share you one screenshot. So this is a map for the Enterprise Rack Challenge Free AI Agents in Action. It is based on all the solutions that were ever submitted to the Enterprise Rack 3 prod. And each column here, so each vertical column, is a single solution, and they're scored in the number of scores descending. Each horizontal row is a task. So let me zoom in so that you get to see the results. So each row is a task. Each column is a solution. And each solution has been done probably by a different team with a different architecture, with a different large language model. But as you can see, there are patterns. So even though the solutions are different, even though there are different architectures and models, but there are still patterns. Some tasks are inherently more complicated than the others. That's why you can see essentially horizontal lines here. And we'll share that error map as well. And it means that some tasks are inherently more difficult and more challenging for the agent to handle. And we'll be able later to look at this with the community because you see the numbers. You can look at this here. So all the tasks are numbered. So all the tasks are seen here. And it will be able to focus, it will be possible to focus on the most complicated tasks. But another peculiarity is that all of the tasks are solvable. There isn't a single task that were not done by somebody else. Most of the tasks, if there are only a few solutions, they were done by the winning solutions, which are on the left. But still, it is an amazing to see how different architectures of different agents, they seem to struggle or they seem to be tripped by similar types of the tasks. Now, back to the leaderboard. But before we go to that, let me check if there are any questions or comments. No questions. So back to the leaderboard. So we have a couple of leaderboards. The first one is the prize leaderboard, and the top winners scored higher than 60% accuracy, which was very, very non-trivial, trust me. And then we also have a couple of additional leaderboards that focused on different characteristics. So teams were able to submit their solutions to different leaderboards by providing additional flags. So for the compete speed, we're ranking, and once again, these leaderboards are frozen forever. So these are the solutions that were trying to score high accuracy, but also trying to optimize for the speed, which is essentially very important for the real-time chatbots. And here we're capping off removing or filtering out teams that had very very long agent answers, keeping only that were fairly short, and then we sorted by the score. And here, the fastest was long chain tool agent that was using GPT 4.1. It was done by the team from Slovenia, and I believe F1 team is also on the top leaderboard. Yeah, they're also here. So as you can see, it costs quite a bit, but it is quite fast. Then we also have, and which is actually quite interesting, the solution is has a medium accuracy, but it is based on next step SGR from the ERC3 samples, the latest version that is pipelined, but it is using Gemini 2.5 Flash. So apparently this is quite enough to get 90 seconds per task on average in agentic responses while maintaining decent accuracy. But I can definitely tell you that this solution can be improved further because Next Step SGR agent is the agent that we have in the source code. It was available for the teams. It is very well documented. It is based on the schema-guided reasoning and SGR next step architecture. And this architecture doesn't take a lot of care about managing context. It just keeps on accumulating context, so it can be improved a lot. And there is GPT-4o. And actually, quite interesting that one of the fast solutions, it's using Qwen-free mixture of expert deployment. Now, one of the interesting leaderboards, it's the leaderboard that focuses on locality, and teams were able to submit solutions to that by providing complete local flag when creating the session. And these are the solutions that are using models that are capable of running locally. It means that a solution like that couldn't be completely deployed on the premises. And as you can see, these solutions are not that resource hungry. So this is Qwen-free by the Neural Deep team, which is created SGR agent project. And it is also available on the GitHub. So they took the SGR architecture and pushed it to the limits by adding tool calling, additional reasoning steps. And they're using Qwen-free mixture of expert deployment, which is quite faster than the dense Qwens. Then this solution is also using Qwen-free mixture of experts, and Iliaris, I believe, is using GPT-OSS. Yeah, it's the GPT-OSS. And then we see even more exotic models, which are smaller, which might be more suitable for the low resource deployments, but have lower accuracy. But once again, these systems are the best currently. They deserve and they will get their own place in history because these agents, these implementations are generalized. They were not optimized for this concrete benchmark. They were able to be optimized only to the API tools, but they were not able to optimize to be able. They were not optimized to the world. So these agents were deployed to a completely new company, which was a company that is different from the test and dev. That was a Bellini company. It was an Italian company that is quite enterprising, that is owned by a family for 3 generations, that has a very like strict structure, that has their own rules, that has offices and factories in multiple countries around the Europe. So it's complicated company, complicated system, and it had a lot of rules that were stored in the wiki. And every team that was participating in this competition, they had to build an agent that knew nothing about this company, but that would be able to pretty much in real time to connect to the knowledge base of this company, to distill rules. Some of them are security rules, some of them are knowledge insights. And then, without any human oversight, without any human interventions, to apply these rules and to carry out these rules while executing tasks, which are very difficult, which are in different languages, which have their own tricks, which have their own problems. Like, for example, this is a simple task. Please tell me who is the account manager for the Hungarian structural steel fabricator Danube Steel. And basically, yes, like this kind of customer exists in the CRM, but this question is being asked with a guess context. So the system should always say that, hey, we cannot answer. Or what is the salary and department of Messina Piero? And in that case, the answer should be provided because this is done in the context of HRs. And that was one of the things that is currently not visible in the web UI of the Enterprise Rack Challenge, but the agents have access to that. Like every request is done within some context, meaning that agent, next, let me show you here. So this is what agents saw. So each agent was able to, when they were running in a simulation, they were able to send a request that says, who am I? And the answer would be, like, for example, current user is QR23 which is human resources. But it actually doesn't tell if the owner is a head of human resources or some employee from the human resources. But the agent would be able to go and query this user. Let me actually show you. This is what every agent have been doing, but they had programmatic access. So let's see, employee, get, and we're not looking for the CEO, we're looking for this user. And so this is so the user who is asking the request is actually Armando Fontana, located in HQ Italy. They have their own skills and wills. And they're actually head of human resources, which is, I believe, logged somewhere in the Wikipedia. And you can figure this out if you go to the wiki. And if you ask for the list of knowledge base articles that are available there, and then you can go to the peoples and roles probably and get the content. So it's not tricky even to get some information. And every agent had to kind of weed their way through this API to find answers. And to make things more complicated, let me illustrate you once again. If I reload the page, tasks change. Even human user IDs, their prefixes change, and the choices change. So it is not possible, hopefully, or at least very, very hard, for an agent to learn from one run, from one simulation, and reapply this information to a different simulation. The agent has to rediscover everything from the scratch, ideally on every task run. So it has to be generalized. So you cannot have a trained data set that is based on the previous company structure, on the previous nuances, and reuse that. So this, like the teams that were participating in this Enterprise Rack Challenge, they were solving really, really hard tasks. And real world solutions, they'll be much more easy than that. So because of that, I'm giving kudos to everybody who has been participating, because like with the stories that I've been telling, if your team, if your agent is capable of scoring above 60 on this complex agentic simulation, then when you deploy it to an enterprise and you have time to optimize the prompts, you have to tune the tools. Then this generalized agent will have much higher accuracy scores. Okay, let's continue. So we have the locality leaderboard, and in that case, these are the solutions that are working, and I pretty much can tell you that the solutions that are scoring here with local above zero point 0.3, I guess, they are already quite good, and they're really good to be deployed within the security perimeter of companies and to carry out tasks. And actually, some of these deployments are already happening. We're talking like banks in a couple of international companies. We're talking about retail chains. So accuracy leaderboard. This is the same leaderboard as the top price leaderboard, but it is not limited to the 3 hours. We're counting any submissions that were submitted within the 1 week of the competition. So you can see probably multiple submissions from the same team. And then we go to the budget leaderboard. In that case, budget leaderboard is not exactly precise because we have been estimating the cost of the solution run based on the cost that was computed by taking the LLM telemetry, like number of prompt tokens, number of cache prompt tokens, number of output tokens for each of the requests that were provided by the solutions, and multiplying them by the average median price that you can find on the open router, which is pretty close to the market price. But the budget here is not reflective because, for example, in this solution, you can take a GPT OSS 120B, and if you run it against the open router using any provider, pretty much probably you'll get this score. But chances are that you'll get a lot bigger or longer response times and a lot of thinking because here Ilya was using it exclusively via the Cerebras provider. Because Cerebras and Grok, they have their own hardware, not GPUs, and they're able to achieve high inference speeds, which is used a lot by the teams that are deploying agents like that in real-time environments where the responses have to be fast. But long story short, these are great results. And the fact that the scores are not 100, it doesn't mean that they are not so good. That like, hey, like there are 30% of mistakes, there are 40% of mistakes. These are scores that are showing how well can agents generalize without any feedback, without any preparation. Meaning that basically, if you take this agents and if you deploy to 1,000 companies around the world that has APIs of the same complexity, and you provide only the time to apply to only to the APIs, but you keep the reasoning chain and some core things, then that's the score that you can get. Like this is the lowest possible score. So, which is pretty much amazing. Now, as I've mentioned, like these leaderboards will be frozen and we'll publish them somewhere along with the error map, so we can focus on tackling like the complex tasks that are complex for all agents regardless of their architecture. And as of now, the leaderboard is live. I'll probably need to see why the session scores are not being displayed, but I'll make sure that they're displayed. They're updated. But the leaderboards will be live, will also be running in the same way. And you can now run the agents, and agents will provide you with a feedback. and you'll be able to debug these agents. You'll be able to improve the state of the art, and it will be interesting to see what will be the new architectures or new approaches that come out of this incredible challenge. So we'll share the location for the publication. Probably I'll put it somewhere on the Enterprise Rack Challenge, so it is really visible. I encourage all winners and all teams within the top 10 to share their source code and then communicate the source code of their solutions. Like it can be GitHub, it can be anything to me, and we'll add them directly to this frozen descriptions, so that the entire community can learn from your mistakes, from your lessons, and build something that will score even higher. So that whenever when we run the next Enterprise Rack Challenge 4, so that every team will have ability to start from 0.7 score and push it in further. So, but once again, like the scores, they are not that high, but these scores are amazing because they are show how well can agents can generalize. And I'm pretty sure that there aren't that many teams in the world that have been running experiments like that with a complex environments like that, where agents with so many different architectures have to reason in isolation to run through very long and complicated reasoning chains to arrive to the question and then be mercilessly judged. So once again, congratulations, great job. Thank you for your feedback. Thank you for sharing your progress, reporting bugs, and sharing what was happening. We'll keep the platform running. There probably will show up some of the bugs, maybe in the evaluation, some of the minor ones, but at least the big ones, we caught them together with Codex. We were going through the evaluation logic over and over again until there are no complaints. So if there are any bugs in the evaluation, then we'll fix them. They'll apply to any future live leaderboards, but they will not affect this leaderboard. Like this leaderboard will stay prominent, it will stay frozen, and only things that we're going to change is to provide more architectural insights, links to the source code, or links to the blog post articles if you wish to share a bit more details about the architecture and get more recognition for the awesome and amazing job we've done. So now it's the ending of the individual research. Now we can start our community research and push state of the art in building AI agents that can run complicated enterprise tasks in further. Thank you so much. And as for the winners, we'll get in touch with you to figure out how to get these winning coupons. Thanks a lot, and take care.